and today I'm going to tell you about how we use machine learning applied to market research at Streetbees, and how that can give us some better insights when compared to more traditional methods within market research. So what is market research? So a lot of our clients are in the food and beverage industry, and they're interested in asking the question, like, what motivates you? So if you think back to eating your lunch, I might ask you then, why did you pick that? And some people just say, I was hungry. That's a big driving factor. But there are other motivations, like maybe you felt like being indulgent, or maybe you wanted to pick something healthy, and there's lots of other reasons as well, like wanting a light snack or wanting an energy boost. And understanding these motivations is really important for our clients so that they can innovate, build new products, and actually help them with their marketing strategy too. And traditional market research surveys might not give you all those options and might present you with a few tick boxes and ask you, why did you eat whatever you had for lunch a week ago, and then you see these boxes and you tick what you think, what you think were your motivations a week ago. And so if you saw hungry, indulgent, and healthy as a few tick boxes, you might just say, oh, I was hungry and I wanted a big meal, I was feeling indulgent. When actually, in reality, it's just because those boxes are in front of you and they might not be your real motivating factors for choosing that meal. So this has two big problems with it, and at Streetbees we resolve this in two ways. So if you're running a market research survey, what you might do is start with a qual group, a small group of people, and ask what motivates them to eat whatever they're having for lunch. But we don't do that. We just have, essentially, everyone's the qual group. We just run large surveys, and we let people say what they want in their own words, not giving tick boxes. And that means that it's not prompted, which is really key because that lets people actually say what they want to say. It's also not claimed. Often it's just when you're purchasing your lunch, for example, when you're eating it, that's the moment we capture. So it's in mobile, in real time, and it's not claimed. So people, really can say whatever they want. But the problem is that that's great, right, letting people say what they want. But the first problem you'll come across is that people have many different ways of saying exactly the same thing. And this is key of how machine learning is used at Streetbees. So just to kind of summarize that, we generate market research insights, which are used for product, innovation or marketing strategies. And we have the benefit of it being not claimed, so in real time via an app. And it allows people to say what they want. So where does machine learning come into this? Well, it comes in two places. The first is really letting people say what they want. So we can use natural language processing techniques and deep learning to deal with, as well as image recognition, to deal with the plethora of things. People can send us images of what they're eating and what they're saying they're eating. So we can deal with that language and process it. And the second thing is to generate insights. So what can we do that goes beyond just kind of bar charts, essentially? What insights can we what patterns can we automatically find within the data? And this helps building our dashboards for clients, so they can then, the ML behind the scenes will be generating the analytics, which you can see then in your dashboard. So today, I'm going to talk to you, I'm going to start with a little bit of an overview of the team, and also what products we build that have machine learning behind them at Streetbees. And then I'm going to talk about 3 of them in more detail before talking about what we're going to look to do in machine learning in the future at Streetbees and wrap up. So the team. So here's a team. We're having a steak. So we're a team of data scientists who might focus more on, for example, like delivering the analytic solutions we develop to clients. And we have machine learning researchers who are more involved with developing like the back end of the products. And we also have natural language processing experts. And we've had UCL master's students doing their machine learning master's projects with us. So kind of a lot of different expertise to help us build these products. So what are these products? So the first one I'm going to tell you about is our clustering app. So essentially, a lot of our clients are interested in understanding what are the behavioral segmentations that exist in data, in our data. So for example, as I said, a lot of our clients in the food and beverage industry, they'll be interested in, okay, so why are people snacking on sweet foods? When do they snack on sweet foods? Is there a product we could build that could fill a gap, for example? And so what we do is we create segmentation. So for example, we might find segments of people who submit survey responses, and they're just having a midnight snack of chocolate. And some people want an energy boost in the afternoon. And with that data, with every log, every submission to the survey, we can then cluster them, but automatically. And the idea behind this is that you then don't need to be a machine learning expert to run a clustering or find patterns within the data. So yes, another tool we've developed is our driver analysis tool. So this is useful for clients who may be interested in understanding what drives certain behavior. So for example, if you want to build a premium product, you might be interested in, when do people buy premium products and why do they buy them? And what we can do is use a lot of the data that people have submitted. So if you take each submission, you can see how they describe that product. Maybe they talk a lot about the packaging. Maybe they talk about it being environmentally friendly, for example, and other factors. And then we can build an algorithm, so a supervised learning algorithm, which can predict, whether that log saying all these things is going to lead to a premium product purchase. And that's great. Okay, so at that point, we've then got a machine learning algorithm which, given some data, will tell you if the product's premium or not. That's not that useful to our client, right? They want to know what strategies they should employ to create premium products. So then we need to sort of make the black box machine learning algorithm more transparent, and we do that using like explainable AI techniques, which basically allow us to explore that space. Technical difficulties. Amazing. Magic. Yeah, so the third thing, this is really important at Streetbees, is dealing with autocoding. So what is that? So as I said, a lot of the approach of Streetbees is based on letting people say what they want, taking pictures of what they want, saying what they want in their own words. But actually, that's great, but there's so much like granularity. We do actually need to be able to kind of tag submissions with, for example, here's an image of someone's lunch, and it's a chicken salad, and they said, I'm having a protein salad. What our clients want is to be able to label that with chicken and salad. And just that, they want to then look at insights based on, what people are having with their salads, for example. So a big part is working on a machine learning process to tag that data. And finally, we also have a brand tracking solution, which uses a combination, actually, of our clustering app and also our topic modeling approaches. What is brand tracking? So brand tracking is basically if you're a big brand and you want to know how is your brand doing in comparison to other brands within your category, we can help you track how you're performing within different behavioral groups and how you're performing across different attributes, different topics of interest. So I don't have time to talk about all of these, so I picked a few, and I'm just going to try and tell you at kind of a high level some of the machine learning that goes into them. And the main takeaway message I want to give you is that actually behind each of these products, there isn't just one machine learning algorithm. It's not like import sklearn and there's just one method. There's like many, many, many algorithms often behind the scenes, lots of machine learning just to produce like one output for a client. So the first example of this is auto clustering. So I'll see if this works. Oh, it can't be loaded. Okay, forget it. But basically, this image just shows you how this was actually for a particular client where we were looking at personal care and how people wash their hair. And basically, we want to, we're logging moments of people washing their hair, and we want to, what we want to do is represent this data, this high dimensionality data, in a lower dimensional space and cluster that data so that we can see behavioral segments come out. And they were really interesting. There were things like people who maybe like wash their hair 10 times in the evening or something. They spend an hour, it's like a spa for them. And other people who maybe just like 2-in-1 shampoo or go to the gym really quick, like they don't care. And it's really interesting to see who are these people, when are they washing, what kind of products do they need for their use cases. So our auto clustering is used such that we can, as machine learning researchers or data scientists or not as non-technical people, you could ultimately cluster data and find those insights yourself. So here's the pipeline, and I'm going to sort of briefly outline what happens as you go through this pipeline. So what happens is we get these submissions in. And to start with, it comes from the top. We have this data. We might need to one-hot encode it or label encode it, depending on what features come in. And then we might need to clean the data, make it proportionally representative of like gender, for example, or income. Or embed open text in a representation space. And what that means is that it means that the vector, I'm feeling happy, it's like, how are you feeling about washing your hair? If someone's saying, I'm feeling happy or I'm feeling jolly, those will be pretty parallel to one another. But if you say, I'm feeling sad, that would be anti-parallel. So that's what we need to do. We need to embed all of our data and group it together. And then we need to take that data. So we've turned our data into like numbers, which we can compute. And dimensionality reduce that data. And we need to do that because it has high dimensionality, and there's this like curse of dimensionality problem, which if you cluster data in really high dimensions, basically all data is then the same distance apart from any other data point. So we have to do a dimensionality reduction of that data, and we use UMAP. We've got our own UMAP, if you know what UMAP is. It's like PCA, but for nonlinear data transformations. And we actually, we then represent this data in this lower dimensional space, but we have our own in-house one. We then actually have to do the clustering on the data. I've skipped one thing, but yeah, we have to do the clustering on the data, and we use HDB scan, which is a nonlinear density clustering algorithm, which basically uses, it clusters data points such that if they're in equally dense regions, data points will join together. Is it good? Okay. Yeah. And then, so say we've done a clustering, we still, in this algorithm, HDB scan, so it's a clustering algorithm, there's loads of hyperparameters which can also be fine-tuned. We need an objective function to fine-tune those. So we use Gaussian processes to define some of those hyperparameters. And then we're not even done. Then sometimes what we might have is that we might have data which is clustered into like 10% of the data and 90% of the data. But actually, you need to like subcluster that data. So we have special methodologies for subclustering as well. And then finally, at the end of all that, once you've subclustered and you've got proper clusters out, you have your clusters. You have like the ID of each log, and you have which cluster ID it corresponds to. But that's not that helpful, right? Because I actually need to be able to know what those clusters mean. And so we have various reporting functionalities that uses lots of ML. We use explainable AI techniques again here to understand what is happening in this highly nonlinear algorithm to produce these groups of people. We use some like standard data science statistics techniques like bootstrapping. So does this, for example, does this cluster over-index on like male or female, and is that statistically significant? We need to describe those clusters. And we also use various NLP techniques for describing what's within that clusters using natural language processing. So basically, this one product uses a lot of machine learning. It uses like 11 plus, I think it's more than that now, different techniques, and that's just for one product. So I'm now going to talk a little bit briefly about brand tracking and auto-coding. So let's start with brand tracking. So what is brand tracking? So if you remember me just from the beginning, I said that it's basically whenever you want to track how good your brand is in comparison to another brand within your category. Well, we came up with a technique that uses a combination of our clustering, auto-clustering, which I showed you previously. So it's basically saying how well does your brand perform in the dominant occasions or dominant behavioral groups. So maybe if you're, Cadbury's, you might be interested how well you perform in that midnight snackers group of people. But also there's certain attributes you might want to perform well in. So the way people talk about your brand, which aren't necessarily occasions, they're more just sort of people associate your brand with good value or it being having really great packaging, that kind of thing. So we have technology to deal with the clustering, but how do we deal with the topic modeling? Well, as I said, people have many different ways of saying exactly the same thing. And so we need to find topics in the text that we have to the question, for example, what do you like about this brand? And so we can use, there are some standard algorithms to do topic modeling, and LDA is one of them, latent Dirichlet allocation. And the idea behind this is that there's kind of two key inputs, I'd say. Firstly, you need all your documents, and our documents here are just logs, responses to a given question. So it might be, I think this brand has great packaging, and it's a luxury, I think it's really luxurious, or something like this. And we have the vocabulary within each submission. And we also need to choose a number of topics that we want to find within all of this text. And then we can essentially sort of dimensionality reduce those documents into documents by topics. And this and also topics by vocabulary. What does this mean? It's a really great technique because it's really, really explainable, unlike quite a lot of machine learning. So when you have your topics outputted, your 4 topics, they'll have keywords assigned to them. And so you can really say topic 1, everyone's talking about it being healthy, maybe low fat, maybe they're, lots of vitamins. And in topic 2, maybe it's all about quick, easy, those are the keywords coming out. You can really see that the second's more about convenience and the first topic is more about health. So they're very explainable topics, and moreover, each document can be associated to topics. Each document, each submission can be embedded in this space, in a representation, such that each element of this vector is interpretable, because each element of that embedding of that document is actually a topic. So you can say it's 70% about being healthy and 30% about eating on the go, for example. And the problem with LDA, though, is it's not very stable. It's prone to minor changes in initial conditions. And basically, this means that if you run it once, say you pick 8 topics and you run the topic modeling algorithm, and on the left-hand side, you have your topics, dimensionality reduced into 2D, and on the right-hand side, you're just highlighting over one of those topics and looking at its distribution over the vocabulary. If you run that once with one random seed, that might be different to if you ran it again with a different random seed, or many other random seeds. And so this is a real problem. But what we can do in machine learning is do an ensemble of these LDAs and find the topics that come out time and time again. And I kind of replied to this on a Twitter thread about this, and I think there's a really nice technique, which is a pull request on GenSim, which I've worked on, which employs this an ensemble LDA approach. And the idea is that you have, if you ran that topic modeling algorithm, say you had 10 topics, and you ran that topic modeling algorithm like 100 times, and then you dimensionality reduced that data, and you're just visualizing every single topic, you can see there are prevalent topics that come out time and time again. So the second part of this pull request, which I've also worked on, prunes out data which is topics that are unstable, just come up once, they're not prevalent throughout all the data. And through this ensemble approach, we can get really stable topics. And this essentially helps us with our brand tracking, because we can just combine. We can say, well, actually, your brand performs, when people talk about your brand, you're performing well in maybe the healthy cluster, but you're not performing so well in this like convenience cluster, for example, convenience topic, sorry. And we can say you're performing well in evening meals clusters, but you're not performing so well when people are want fast food, for example. So you can actually see how a brand is performing across demand spaces or behavioral segments and these kind of these topics, and then we combine that to finalize a brand tracking solution, basically. And finally, I'm going to tell you about autocoding. So if we looked at the question, what are you eating? Well, in our submissions that we get back, people might say things like, I'm having a protein salad. And they'll take a picture of their salad. And as I said, we want to label this with chicken salad, so our clients know what on earth people are eating, right? Otherwise, you've got all this open text and images. You can't deal with that. So our approach is to use state-of-the-art language modeling techniques and also image recognition techniques. So we're currently using Roberta to embed our text so that we can then find out and classify and basically tag text with, for example, chicken, salad, etc. So this is used for our open text, and Roberta works, if you know about BERT or language modeling, the way it works is it takes lots of text. Like, for example, if you took Wikipedia and you mask certain words, you then want to be able to predict what those words are, and it uses deep learning and attention to do that. And Roberta is an improvement on BERT because Roberta is trained on more data, basically. And for images, and I should say that we want to basically be able to represent this text in a really good representation space of vectors, because then we can tag more accurately. We can be able to say, no, this submission is about salad, not just about lettuce or something like this. We also want to be able to tag using our images, though, and for that we use ResNext, which uses ResNet, if you know about that. But basically, it helps classify our images, and with one of the nice features of this methodology is that for image classification, we really need deep neural networks. You really need many, many layers. But the problem with that is you can have this vanishing gradient problem in deep learning, where the initial layers, like where the image goes into the network, don't really change much. And ResNet solves that problem by basically passing earlier representations of that image into the network at later points, and so on. So this kind of resolves some of those issues and improves basically the image modeling that you can do in ResNext is an architectural improvement on ResNet. Okay, so how does this work? So what we can do is we can feed our text into do transfer learning, so feed our open text into Roberta, and then Roberta can predict which food types. They eat many heads. This is like different heads at the end of Roberta, and will predict which food is in that open text. And we can also do, and so for example, that would give you, all those heads, it would end up giving you a 1 where it says salad at the end of it, and a 0 everywhere else. And we can also do the same for our images with ResNext. So we have lots of heads, and where you can see chicken and salad, you'll get ones and zeros everywhere else. But then we can also, why have a machine that can speak and understand language and a machine that can see? Why not have a machine that can do both? And so what we can do is combine those machines and have layers which can kind of combine and concatenate those outputs, those final representations, and then classify. And at that point, then we can label this as chicken and salad. So this is all a supervised approach. So yeah, just to summarize what I've gone through. So I've done a really quick description of what we do at Streetbees, how machine learning is used in our various products, from clustering to brand tracking, and our auto-coding as well, which is really important for clients to get insights from our data. Because it's all open text and we let people say what they want. I also just briefly told you about driver analysis and how that uses explainable AI, but also the future of Streetbees. What are we interested in working on? Well, we're still working on areas of those projects, but we're also interested in understanding or putting our data of like users and moments into a graph and then embedding that graph so that we can then make future predictions about behavioral behaviors. So for example, say you haven't got much data on an emerging market, but you have data on another emerging market, and in that emerging market that actually those markets are quite similar, and so because of their embeddings, and actually in that market something's popular, so maybe something will be popular in this other market, less about, for example. So yeah, that's it. And yeah, thank you for listening, and if you have any questions, feel free to ask them now or message me. Thank you.
Thank you. Do we have any questions? I can see a question there. I'm going to limit it to one just so that we keep going. But
that's fine.
Hi, thanks. I'm curious to know if your clients and your users let you train across different clients and projects, because it's users and the way they talk is not that consistent, even though it's just food and beverage for most of your clients. It's humans talking, and it's like social media. There's so much noise. So you could miss out on the most important feedback from them when you do clustering, right? So do they let you?
So we don't, so it depends. So on the surveys, some surveys are for particular clients, and so that data will be kind of really perfect for that exact output. Whereas, especially for the knowledge graph embeddings, which is right at the end, what we're really looking at is looking at data across different surveys and combining them. So we do have to be careful about how we combine data, make it not biased, for example, towards certain surveys, etc. So for example, on the how are you feeling question, if it was just about people who are hungry, just about to eat lunch, a lot of them would just say that they're hungry, and then you'd have this bias in your data. So in your models, for example. So yeah, it is definitely something we're very aware of, and we do account for when we're using these algorithms.
Thank you. Good question then. So so I'm going to get everybody to say a big thank you to Sophia now, and thank you. That was a great presentation. Thank you.